Now I'll be explaining more about how the insertion sort algorithm works. So the coding of the insertion sort can be seen in this example, and I'll be using the data within it to play out about how the insertion sort will have gone with each iteration. So the insertion sort keeps the first number as in the sorted sub array as it starts from the list at the beginning. It then compares the first number with the second number, comparing 4 and 7. As 7 is larger than 4, no swaps happen, and 4 and 7 keeps their position put into the sorted sub array. The rest of the numbers are still left unsorted. In the next iteration, the third number, 1, is compared to the first two elements. As 1 is less than both 4 and 7, 4 moves into the position of the second number, and 7 moves into the position of the third number, leaving the first position empty. So 1 is then moved into the empty first position, and these three numbers make up the sorted sub-array. The rest of the numbers still remains unsorted. So then it takes the fourth number and compares it to the elements within the sorted subarray. As 5 is larger than 4 and smaller than 7, 7 is moved into the fourth position, leaving the third position empty, and 5 is inserted into it. So the fifth number, 2, is once again compared against the elements in the sorted subarray. As 2 is larger than 1 and smaller than 4, 4, 5, 7 moves one position up, leaving an empty space for 2 to be inserted into the sorted subarray. So as the sixth number, 8, is compared against the elements in the sorted subarray, 8 is larger than all of the numbers, and so no swap happens and all of the numbers retain their position, inserting 8 into the last position. So the last number, 3, is compared against the elements in the sorted subarray and subsequently inserted in as well. So the insertion sort is finished, and these numbers are returned in order.